This is my 1979 Super Beetle. When it was originally manufactured, it had fuel injection, and I have since converted it to a standard carburetor. The reason why we did that was for a couple reasons. First of all, electrical components, they wear out and they get harder and harder to find. So we also wanted to simplify this so that it would start dependably, and that's what the carburetor has given me. There's a problem with this installation though, and that is this EMPI carburetor came with a sort of a standard air cleaner. You look at this and say, oh, it's simple, it's just an air cleaner, right? But actually there's some issues with this air cleaner. The other day I was driving around and this air cleaner vibrated off and ended up down here underneath the pulley, and it stalled the car out. It's made a hell of a lot of racket and scared the crap out of me, but I was able to drive home without an air cleaner, and I took a hammer to it and banged it back into shape. The actual filter itself wasn't damaged, but it had given me the opportunity to look at the performance of the filter and the design of the air cleaner, and I think I found it wanting. Let me take it apart and show you where I'm having issues. All right, so with the air filter removed, a couple of things first about the manufacture of this product. When I first got it, the first time I installed it, one of these little connections, the spot weld, failed immediately. It was very disappointing. During the initial installation, I was unable to get the top of the air cleaner connected. So I went ahead and tacked it with a weld, and everything seemed fine. Well, later on, the other tack weld broke, and so I decided, well, after this last iteration, I went ahead and I put a rivet in there. So now I got rivets in there. But this design with its spot welds is very weak, and you can't tighten it down. And when you do, if you don't tighten it, then it'll vibrate loose. So there's, it's just asking to fail. The other thing about this design is the air breather hose. This is the crankcase ventilation that comes from the filler tube. It goes up into the air cleaner. That right here, it comes up and it's on the inside. You can see it's very typical. It's on the inside of the air cleaner. Well, when this car is running, there's I don't want to say a mist, but the oil and it's an air-cooled engine. You can see splatters of oil everywhere here. It's an air-cooled engine, and the oil gets hot, and it causes a steam. Let's just call it steam, a mist to collect. And what that ends up doing is the whole inside of this air filter. I've only had this on. I don't drive it every single day. I've only had it on for a couple of months, but the inside of this thing is drenched with oil. I don't know if you can see. Let me wipe my finger in there so you can get an idea just how oily this is. It's just, it's a mess with oil. Well, what that ends up doing is this paper filter gets impregnated with oil, and that impairs the airflow. And so the car seems to run a little rich, and it'll even flood if you let it. So what I think I'm going to do today is I'm going to take this, like I said, it was a 79, it was fuel injected, and there used to be an air box right in here. And that air box had an air cleaner that wrapped around in this blank area of the engine bay. And that air cleaner was a very large, had a large volume air cleaner in it, and the crank ventilation was separated quite a ways from the air cleaner. The air cleaner was up in this area, and then the crankcase ventilation was closer to in that case, it was a throttle body. And we just replaced the air box and the throttle body with a carburetor. So what I want to do is I want to put that old air cleaner back on and create an airflow that will prevent this crank ventilation from soaking the air cleaner, the air filter, and put that original air box on there so we can have better airflow. So that's what I'm going to work on today. And here's the parts. Here's the old air box. You can see this thing connected on those 2 bolts right there, and the air filter itself kind of set back in the engine bay with this area right here. And if you take this open, there's a couple of snaps here and there. You can see how big this air filter is. There's a lot more surface area, and it's separated from that ventilation, so the crank ventilation, so it doesn't get any oil on it. So I think that's going to be a great solution. Now, this original had the air box on it. The air box was the airflow meter. You can see this is for the fuel injection. It had a little flapper valve in there, and it would report to the computer with these electronics how much air is passing through. So we're going to remove this airflow meter and use some aluminum sheeting and create a shroud that will take it from the square opening here with a round opening here to get it to marry up with this massive opening right here. So we do have to integrate that crank ventilation, so that's going to be the challenge. But we'll figure out a way of making that happen. So let's get started. Okay, so with the air box off, and I've got this kind of just sitting in on these screws where they're going to be mounted, you get an idea of the geometry. I need to get the air to flow from here going horizontal to here going vertical. And I also need to engage this this vent, the crank vent. You can see that right there. So the other good thing about what I got going on here with this possible solution is this used to be connected to the air vent, and so it has sort of a, I don't know if you can call it a gasket, but it has a sealing surface, and it has some registration knobs. So these 2 holes and these 2 holes where I have this mounting bracket mounted temporarily, they will be able to help me for mounting the piece of plenum that I'm going to make here. It's going to kind of turn. It's probably about 20 degrees, a little 20-degree turn here, and it'll go from square to round, so that we can get it to interface back over here. So that really makes it a lot easier for me to utilize this, because it gives me 4 bolting points and 2 registration points, so it's not going to vibrate around or anything. So that's really good. The other thing is, I was realizing this actually also gives me a hot air warming. So it has a pipe that go from here to the front side of the air filter that will help to warm the car when it's cold out. So that'll be helpful as well. I do have to plug some of these vacuum tubes that we're not going to be using, but that's not a problem to plug a hole. So. All right, moving forward, let's take some measurements and get an idea of how we're going to move from here to there across this small section and still engage this bracket hole right here. All right. So initially I was thinking I was just going to try to reuse this plate because it has a nice mounting surface that you can use very easily, put a little pipe clamp on, and it'll clamp that off. But on further inspection, I mean, even when it's flat, perfectly flat, it interferes with this little screw, and it has little holes. So there's already a vacuum leak right here at the top of the air cleaner. So that was something that was already there that I didn't even know about. And the one back here, this thing doesn't even fit. So we're going to toss this thing out, but use the same kind of concept to get a pipe clamp right in here, but we got to figure out how to get it to go from here to there. So the other thing is we need to get this crank involved. It doesn't have to be right here. I think what I'm going to do is I'm going to change the routing, and we'll connect it right here, right as where I'm going to have to make a metal transition from here to here, a little plenum. So I'll put a plug in that plenum for this to go directly up. And the advantage to that is I can actually put a little bit of a cavity in that, so that if any of the oil that the mist that comes up in here does condense, because you know airflow will make it colder. You got hot oil and hot steam coming up, hitting the cold airflow. That oil is going to condense. Well, you don't want it just to drip in and burn off. So if I put a little bit of a cavity right in here, that condensation can fall back down this breather tube and go back down into the engine, and the engine will burn less oil. So that's a good thing. So I like that design. We're going to change this from being up here to being over here, and I'm going to integrate it into this plenum that I'm going to build for right here. As far as this goes, I'm going to have to probably hit the hardware store or the auto parts store and see if there's a smaller rubber boot that I can get for this, because you know the engine vibrates a little bit. This is mounted firm on the frame right here. This doesn't move at all. So the engine's going to move, and this doesn't move. So there's going to be a little bit of a movement that's going to happen in here. So a little bit of a rubber connection or an expandable connection right in this area is desired. So I'm going to have to do some shopping. I'm really disappointed in this EMPI air cleaner. It doesn't fit. It doesn't work. It's poorly manufactured, and I mean, I guess that says it all. It's just a POC. All right, moving on. Okay, so I'm back from the store, and I've got a solution. This is a little $5 little 2-inch joiner. Got this at the hardware store. It's a nice piece of rubber. We're going to put that right on here because this has a 2-inch outside diameter. And then that will be a spacer that I'm going to use for this original boot. This is the boot that went on the fuel-injected engine. And it used to look like this. It would sit on the throttle body kind of like this, but the throttle body in that case was back in this little gap right in there. It used to be like way back here, but you see it's a little off, and you can't really just use it directly because it kind of gets all over the place. But the advantage to using this particular boot is it has, there we go, right there. It has a crankcase return line. So this is where the return line was for the crank, right here, and it's flexible. So if the engine's moving, and you know, it's exactly what it's made for. So having a little elbow in there is going to be perfect. And see this little flexible section right here will keep the engine from pushing the air cleaner off. So we're going to put this old boot into service. I'm debating whether I'm going to cut it in one space and just use a portion of it, or if I'm going to twist it into a right position. But regardless, that is going to be the solution, is to use the old boot in its place and point it over at the plenum. Now the plenum right here, then, well, I'll just have to go from a square hole to a round peg, and that's pretty standard. I've done that a number of times, so that won't be too difficult. All right, so moving on. There you have it, all cut up and fitted. You have plenty of flex with this little boot, and back here I've got a fitting that will connect to that crankcase ventilator right there. I just have to plug one end of it off, but this is the right size right here, so I just turn it down and plug it in, and off you go. So that's all handled. All we need to do now is make the plenum. Now the question is, what should I make this out of, right? Initially what I was thinking was I'd make it out of aluminum and make a little box with a hoo-ha over here. But now I'm starting to think, you know what? Maybe melting some PVC into a form might be a little cleaner way of doing that. I get some Schedule 80, it's the same color, and you never know that it wasn't store-bought. So maybe that's a method that I can test that out and see. If not, then I'll just go ahead and do it with a standard aluminum box. All right, so for this next exercise, we're going to do some shaping with heat by shaping this PVC. This is a piece of Schedule 80 1.5-inch PVC. I really wanted some 2-inch just to make it so I had a bigger inside diameter, but I went to the hardware store and didn't have any. So we're going to make this work, and we're going to stretch it if we need to increase the inside diameter. But what we're trying to do is make a square hole into a round hole. And so we're going to use this PVC. What I've done here is I've cut notches so that I can have a 2-inch flange. These 2-inch flanges, once I get those melted flat, they will correspond with the thickness of this right here. So we can drill 3 holes, 2 for screws and then 2 for the notches. And so basically what's going to happen is these flanges are going to go in this little area right here. And the angle for right here corresponds with this angle right here. And that should give us, once we get it, it'll give us a connection that will connect this, this round hole into this square orifice here. And the cool thing about heating PVC is that it doesn't really become, too soft, but with some, gentle massaging with some metal materials. I got a little piece of sheet metal here. I'm going to be pushing if I need to get it on to, to flatten it out and whatnot. But you can make it a shape into just about any shape that you need. I've seen people working on pools that take torches and they use an open flame to make the PVC malleable, and they'll bend a corner instead of putting a piece of joinery in there. So you can do a lot with heat and PVC. Now, I know what you're thinking. Engine compartment's hot. How's it going to keep its shape? Well, it's not that hot. There is a significant increase in the temperature that we're going to have to get this thing to. And if your engine bay gets hot enough to melt your PVC, you got other problems going on. I didn't cut the length. I figured I would take and do the flange. It would give me a couple of opportunities to screw it up and get it right before I ran out of length. But I think I can get this in one go. So let's go ahead and heat up the heat gun and get this thing melted. Like always, safety first. I don't usually wear gloves. It's not my gig. But in this case, I'm telling you, it's going to get hot. I don't want to burn myself. I've got a flathead screwdriver. Nice big flathead screwdriver. I've got a putty knife for working large areas if I need to squeeze and push things. And if I need to expand, I have a pair of pliers. And the idea here is that you have a hole that you want to get bigger. You can increase the pliers and it will open up those holes. So that's the plan anyway. It'll be like an expander of sorts. It gives you the ability to expand those holes. All right, let's get this thing heated up. Let's hope I don't trip a breaker. Let's see what we got now. See, it's starting to flatten out. That's nice. And this one's going to go way past. It's going to go like this. Okay, we're trying to get this in pieces. Well, the advantage to the Schedule 80 is it's nice and thick. So once we get it into the general shape, you can actually, grind it down a little bit too. But this looks pretty good. I think we're making some good progress. I'm going to try to keep this flange nice and flat while it's cooling. So you get the idea. A nice flat flange. The next thing we're going to be working on is making sure that we don't have an obstruction in here. You can see how it's caved a little bit right here. So we're going to work on managing that. But we'll be working it back and forth and making sure that we get a good connection. But, all right. Let me work on this side a little bit over here too. That's pretty good. I like that. Just a little bit warm. I'm glad I'm using metal and got some gloves on. Putting a little leverage on here just to stretch this out on this corner. Trying to make that a little more square. Kind of like putty. Then all of a sudden it'll get nice and hard on you. All right, this side. All right, those edges have gotten nice and square. There's a nice flat flange. Look at that. All right, I'm going to tidy this up a little with some grinding, a little sanding, so we can get some nice flat edge in here. And then we'll throw some screws, some drill holes in it. So there we go, all mocked up. You can see the mounts are in place, all the bolts and brackets are connected, screw holes are in the right spot. Everything's connected up in here. I have clear access all the way through. You can see it lets out right at the opening right there. So all we need to do is adjust the length of this tube and figure out how to get it so I can clamp on the end of this boot. And this boot right here will give us the flexibility that we need, you know, for the engine with this little hoo-ha right here. That'll keep it so that when the engine vibrates, this won't be vibrating, but it'll be able to react a little bit. So I think I'll probably take about a 1/2 inch off of that, and we'll put this boot on. The boot will go something like this. Maybe take a whole inch off. I have to see what it looks like from the top. But looks like we got it worked out. All right, moving on. Let's get this thing all clamped up. I'm gonna have to put some silicone sealer in here, but it looks pretty good. I got some really good geometry matching up. I don't think we're gonna have a problem with the flow. So here's the boot all installed. Got a nice hose clamp on here. It does not encroach on the choke at all, so that's good. We don't have to worry about that linkage being a problem. It's all good. Everything looks like it's going to fit. The PVC is clamped in right there. Had to put a longer hose on, but it's got its place to be now. Instead of going into the air cleaner, it goes directly right here into the boot. Now, the advantage to reusing this boot, and you can see here's the little bellows right here, is that the engine's going to vibrate, but the airbox is not. So this is, I mean, we'll get a lot of play out of this boot without any kind of interference with the airbox. So that gives us the flexibility that we need to pull this off. Let's go ahead and get that airbox up. I need to throw some silicone on that seal and just get it installed. Well, there you go, all installed. You see on the boot, I had to cut little grooves where these ribs were so that the pipe clamp wouldn't slide off the end. So that's good. Everything's nice and snug. You know, we're going to get the vibration that we need from this boot. The cover here pulls air right from the air intake on the top of the engine cover. And everything fits perfect, just the way that it was designed to fit. And now, if we choose, we can actually put a pipe right here to connect it for a heat riser to warm the car up. If we choose to do that later. I don't know if I'm going to do that just yet. But let's go ahead and fire it up and see how it runs. All right, so there you go. See it running. I was talking about the vibration. isn't, because the boot gives it space right here. So, really happy with that. The choke is running right now. As soon as the engine warms up, it'll back off and it will run a little smoother. But I think we can feel a little bit of air blowing in here. More air blowing down here than there is up there. But it's pulling air from here and there, so we've got a really nice air cleaner. We don't have to worry about that old EMPI thing falling off in the middle of running. So to review what we did today, or in the past couple of days, we initially had a problem with the air cleaner that came with this EMPI carburetor. When I first installed it, the little bridge that you get that is normally tack welded on the bottom of this plate, it broke when I tried to tighten it. So I tried to tack it again, and then driving down the road, it fell off again. So I went ahead and put some rivets in it, and finally I decided that because the crankcase ventilation tube is so close to the paper on the filter, that the filter was getting saturated with oil. I don't know if you can see. And that was impairing the airflow. So I decided, since this was a 79, I decided to reinstall the old air filter, which the old air filter was connected on the side over here, and it had an air box right here. So we did an air box delete, and I replaced it with a piece of PVC that I bent into shape. You see I've got a custom flange bent here and a little bit of a bend in it here to make up some room to fit onto the original boot that connected to the what used to be a throttle body. And so now the throttle body has been replaced with the carburetor, and there is no air box. But this boot gives us the ability to absorb the vibration of the engine running, and that makes it so that we can install this old air cleaner. And that was the project. So if you have any questions or comments, throw them in the comment sections. I usually answer those pretty quickly. That's all I have for you this week. Cheers.